Okay, welcome back. We're still looking at sexual selection. We're in video 3, and here we're going to focus on mate choice or intersexual selection. We'll focus primarily on female mate choice. Why are females choosy? And so we need to get to wherever we are, where we've finished. Here we are. This material is more heavily covered in our Mother Nature book. The Mother Nature focuses on mothers, so no surprise, there's more information about female choice than about male-male competition in the book. So there are some examples that come into play from our text. So here we are thinking about questions like, why are animals choosy about their mates? Especially females. And this question is kind of a question asked in the ultimate sense. Why did choosiness evolve? How can being choosy be adaptive? So why has choosiness been selected for over time, if you will? There are lots of models about why female mate choice, the ability to select some males over others, why that benefits females. How does that enable females to be more successful, produce more offspring that are survivors, right? So let's take a look at some of the models. The first model is the direct benefits model. This is pretty straightforward. Sexual selection favors females who choose males that provide them with tangible resources. Oh, choose a male that's going to provide you with some tangible resource that enables you to increase your reproductive success or your fecundity, for example. A great example of a gift of resources, if you will, are pre-copulatory gifts. A lot of nuptial gifts. A lot of animals, a lot of males, when they're courting a female, will bring with them some gift of resources, a tangible set of calories that the female can use when she's yolking up clutches of eggs, or when she's gestating, whatever it is, okay? So sometimes males will give females a resource, a packet, prior to mating that will increase her reproductive success. Females should choose males that bring the best gifts, right? Lots of insects bring edible nuptial gifts. So they will transfer their sperm in a packet of sperm called a spermatophore, and that spermatophore is also edible and has nutrients in it that will enable the female to survive well, right? And raise more young, presumably. Scorpion flies, for example, bring a gift of food, and females prefer males with a gift. So they don't like to mate with males with no gift. They're like, no way. The bigger the gift, this is really fun. Listen to this fact. The bigger the gift that the male brings, the longer the female will mate or copulate with that male. Bigger gift, longer copulation. Why is that important? Longer copulation means more sperm are transferred. So this benefits males. Male traits that should be selected for then are traits that enable the male to make big gifts, to bring big nuptial gifts along, right? And in fact, we see that males will often discard small gifts. Like these scorpion flies bring prey items to the female, and they'll see a small prey item, they won't even go for it, because they know that getting a big prey item or bringing a big nuptial gift is most successful. So this ability to recognize prey size and to discard small prey has been selected for over time because of this female choice. Males will even steal the nuptial gifts from other males in these scorpion flies. So females certainly benefit from pre-copulatory gifts of resources. She might be able to produce more eggs, or the young may have a higher survivorship, a probability of surviving. Here's a couple other examples. Chimps will often give meat resources, like dead monkeys, to females. Redback spiders, the male actually gives his life after mating. Female eats them. What about humans? Females do prefer to mate. Evidence has shown from this research with David Buss that females prefer to mate with males who have more resources or more earning potential. That's evidence that maybe supports this idea that there should be selection for pre-copulatory gifts because females prefer them. They enable her to raise more young successfully. Here's another direct benefit. Perhaps females select males who are going to be better parents or are going to provide more care for their offspring. Females choose males that will provide better parental care and therefore will enhance their reproductive success. So females should be choosy and find some way to identify whether a potential mate is going to be a good father in species in which males do some care for their young. So we see this in birds, in a lot of bird species, right? That's where we would look, at least because males do a lot of caring in many bird species. And in fact, then we need to look for whether females are preferring males that end up being good fathers and how they make that decision, right? How can you tell that that potential mate's going to be a good father? What traits does that male show? Well, in house finches and pied flycatchers, we kind of get the similar type of strategy. In both of these, females prefer males that end up becoming better fathers. And it turns out that in pied flycatchers, male plumage is like the color of the feathers. This is a beautiful little pied flycatcher. The plumage color can vary from really bright black, deep black, to brown, kind of drab. And females prefer the black and white plumage. Turns out that males with black and white plumage are better dads than males with duller plumage. They provide their young with more food than these duller males. So females have found a way to select males for their parenting skills and select them quickly based on color in this case. So this would be a direct benefits model. Females are going to benefit by selecting males who are going to help them care for their young. Here's the next model. It's called the good genes model, or the indirect benefits model. So in this case, males that females are choosing don't give a nuptial gift or aren't going to do any parenting. So why should females be choosy? Well, sometimes females can be selecting a male of good quality. So in this case, a high quality male will provide good genes for a female's offspring. And a female could benefit indirectly by picking a male that has good genes, because her offspring will inherit those good genes and therefore be more successful at surviving and maybe reproducing down the road, right? So are there indicators of quality in males? Could a male's size or his color or his display rate or his call be a true indicator of, hey, I'm a good quality male, and because I'm a good quality male, you should mate with me? Does this happen? Absolutely. Females seem to find traits that indicate, honest traits, that indicate that that male has good quality genes. What kinds of traits? Let's look at the example of pronghorn antelope. If you've ever been out west, you've probably seen these beautiful animals. It turns out that in this species, a single male will defend a harem of females during breeding, and he will have access to mating with those females. Females, and I'm going to switch the slide here, And it turns out if we look at this graph, and we look at the number of males who sire fawns, most males, that's the 0 to 1 category, 60 of the males in this population that they were studying in Montana didn't sire any young. Some males sire 1 young. Even fewer males sire 2 or 3 or 4 or 5. Oh wow, 1 male sired 9 young during that year. Wow, that's a cool one. That's a good male. What is it about how would a female select a male that is of good quality genes? Well, it turns out that females prefer to mate with males that are defending a large harem of females. Males that are defending a large harem of females. And this seems to be an indicator of good genes. If you're a male that can defend this bigger harem of females, chances are you're a good quality male, right? Is there real evidence for that? Let's take a look. So in pronghorns, females prefer males with large harems. This may be an honest indicator of good genes in male pronghorns. Why? Like I said, it probably shows that you have the ability, the stamina, the strength, the intelligence to defend this group, right? And what these researchers looked at, and it's kind of interesting, the researchers looked at probability of survival and offspring age. So how likely is it that offspring are going to survive? And they came up with a curve. Oops. Let's see if I can get back there. Wow, this is not being happy with me. That's how it goes, right? They found a curve. Okay, so in males with large harems, their offspring have a higher probability of survival during most of the offspring's life than do offspring from males with small harems. In other words, if you decide, if you're a female and decide to mate with a male who has a large harem, your offspring have a higher probability of surviving than if you mate with a male from a that's holding a smaller harem. So, choosing a male that's got a large harem is the way to go. It's going to benefit the female. Females should select males who have good quality genes. This may be a way that a female can make that choice in terms of antelope. But on the other hand, won't selection favor males that cheat, that kind of pretend to show off good quality genes, even if they don't really have good quality genes? Can I be a cheater? Can I pretend I'm good quality? Females typically look for, can males advertise falsely that they have good genes? Typically in different species, females try to find honest signals that honestly advertise good quality genes. So they look for costly traits that are difficult to fake. In frogs, for example, females prefer males that make loud calls. Loud calls are hard to fake. If you're a small frog, you can't make loud calls. That would be an honest signal. Or in peacocks, females prefer males that have lots of eye spots, lots of color, long tails. These are hard to fake. You have to be a good quality male to be able to make that kind of ornamentation. And it turns out if you can do that, your offspring will grow faster and be more likely to survive. So this is an honest indicator. You can't fake it. And that's what there would probably be selection on females to choose traits that are honest advertisements for good genes. That's tricky, right? Because males are going to try to cheat left and right. Here's another piece of the good genes model. It's a little bit different, but it's called the healthy mate model, and it has to do with parasites or parasite resistance. So these researchers named Hamilton and Zuck came up with this hypothesis, and it's really a good genes model, but the idea is if males have genes that give them parasitic resistance, females should prefer to mate with these males. All right, disease is a disaster in the animal kingdom. Disease kills left and right. I want to show you a video. I'm getting back to our slide and getting irritated. Losing the ability here too. There we go. See where we are. So in this situation, and with those poor those poor grouse, it was pretty easy for females to pick out males that are healthy, that have good genes, that are going to incur parasite resistance, because color was clear. Color was a clear or an honest indicator that females could use to identify resistance in potential mates. And this would be an evidence of good genes. The poor guy with tuberculosis not only had tuberculosis, which could spread to a female, but could be an indicator of, hey, I don't have such great immune system. And females should select against males that are in that situation. A lot of researchers have found that color actually is an honest indicator of parasite resistance. Strange. This is kind of a complicated set of data, but really what we're looking at here are in sticklebacks. Females prefer redder males. And so we can see a couple of things. That's the middle graph. So color intensity as a function of female choice goes nice uphill. More colorful, redder males are preferred by females. And it turns out that males that are redder are healthier, have lower parasite loads than males that are duller. So here we've got color intensity as a function of condition or health. So females choosing bright red males are choosing males that are healthy, that have good genes with respect to parasite resistance. Yes. And even when they took the red color out, they filtered out the red color, females could not make a good choice. They didn't make a particular choice, because they use red as a signal, an honest signal that males are quality males that have good health. The good genes model. So that's our second model. Our third model for sexual selection is the runaway selection model. We'll start here in the next video.